Mathematics Applications and Interpretation, Paper 1, Time Zone 1, HL, May 2025. Now, this is question number 2, carries 7 marks. He's talking about a dolphin that jumps out of the water and it reaches back to the water surface at that particular point here. The part of its jump can be modeled by a quadratic function, and using the following variables, he says d is the horizontal distance from the point where the dolphin leaves the water. Basically, I can consider this to be the x-axis and this has the y-axis. So my variable would be a d, and the height is a y-axis. All distances are measured in meters, which is good. We don't have to convert any units. On a particular jump, the dolphin first reaches the height of 5.1 meters above the surface of the water when the horizontal distance is 3 meters. So basically, what he says is that at 3 meters, which is here, the height is 5.1. And the same height of 5.1 is achieved when the horizontal distance is 8.5. The two x values gives me the same y value. This is symmetrical. And from here, he wants me to find out the axis of symmetry of the quadratic function. And then he gives me the model itself. And further, he wants me to find a value for b, find the horizontal when it re-enters the water. When it re-enters the water would basically mean that he wants us to find the root of the equation. There's multiple ways of solving this question. Let's see. If I chose the distance from the origin as 3, and because it's a quadratic function, I also know that the symmetrical value for 3 is 8.5. And therefore, from 8.5 to the point where it is touching the x-axis again, which is the water in this case, that distance is also 3. Which means the complete distance from the initial point to the terminal point here is 11.5, which is simply 8.5 plus 3. And that tells me that the roots of this quadratic equation is 1, a 0, which is here at the point where it is starting to jump. And then another root is going to be 11.5 directly. Now, I can use sum of the roots and product of the roots. So the sum of the roots is going to be 0 plus 11.5, which is simply 11.5. And the product of the roots is 0 into 11.5, which is going to be a 0. So in a way, I can also go ahead and write the quadratic equation. Let's go back and look at the equation that's been given to me. He tells me that the equation is minus 0.2 d square plus bd, which means the coefficient of the d square term is minus 0.2. So I can write the equation as h of d as equal to minus 0.2 into d square minus sum of the roots d plus product of the roots. So this is further minus 0.2 into d square. Sum of the roots is negative 11.5 d. Product of the roots is of course 0, so I don't need to write that. So this is minus 0.d square. So now that I have the quadratic equation, a lot of my questions gets answered over here itself. I can find out the axis of symmetry of the quadratic function. So how do I get the axis of symmetry? I know that the axis of symmetry can be found out using this, which also gives me the maxima or the minima depending on how the function is. So this is going to be minus 2.3 divided by 2 times of minus 0.2. So when is the dolphin entering the water again? We've already found that out as 11.5. You can either do that or you can take this equation and substitute in the solver. In the last part of the question, explain what a negative value of h would mean in this context. The negative value of h would simply mean this. When I'm above the water level, the h values are all positive. Okay, so the negative value would simply mean that the Dolphin is under the water. So you can solve this question in this way, or so because the parabola is symmetric, the axis of symmetry is going to be the midline between 3 and 8.5. Okay. Now, if I have to find the midline between 3 and 8.5, I can simply say 8.5 plus 3 divided by 2. And that's also going to give me a 5.75. So that's going to be the axis of symmetry. So the axis of symmetry, which is 5.75, is also equal to minus b by 2a. So in this case, 2 times of negative 0.2, because I know that the equation of the parabola is given to me as minus 0.2 d square plus bd. So here I can transpose this and get the value for and after this point, if I wanted to find out where is the dolphin coming back to the surface, I can go to the calculator. Those are going to be the roots. So from there, I can say alpha is 0 and beta is 11.5. So two different ways of solving this question. You can choose whatever method that is suitable and what you feel comfortable with. That's it for this video. Thank you.